and homework 62. I figured we'll just put it all together here. So we're going to do some of these together, and then you're going to go ahead and finish the rest for homework. So this is, again, basically just a getting to know you for all of the formulas on the formula sheet, or at least most of them that we haven't yet done. So take a look at what the directions are saying. It's saying use the formulas to evaluate each trig expression, calculate the unit circle values as needed. So if you wind up with something on the unit circle, the sine of 60, the cotangent of 5 pi over 4, anything on the unit circle, you should actually tell me what it's equal to. For anything not on the unit circle, you can just leave it. And I think that that will become clear in just a minute. So take a look here at A. Notice that you have the cosine of something times the cosine of something minus the sine of something times the sine of something. So what you want to do now is you want to take out your formula sheet, or you can just take a look at my copy here. For this exploration, we are going to be looking at these formulas. So these are formulas we haven't yet utilized. Notice that the first 6 are the sum and difference formulas, followed by the double angle formula. So sum and difference is because of the fact that you're adding and subtracting. Notice that there's one for each. The double angle, because of the fact that double means 2. Something to notice for the double angle, there's only one formula for the sine of 2u, and then there are 3 formulas for the double angle for cosine, and 2 formulas for the double angle for tangent, so you have to be familiar with all of them. And then finally, the half angle formula. So the half angle formula has to do with taking the half of something. And again, there are 1 version each for sine and cosine, and then 2 different versions for tangents. So you should have this formula sheet, or you should know how to access it. You're definitely going to want it for today's lesson in homework. So again, going back to 62, you have cos minus sine. So you want to look at your formula sheet, and you want to find a formula that is exactly equal to the cosine times the cosine minus the sine times the sine. And if you look carefully, hopefully you would agree that it's this one right here. So because of the fact that I gave you the right side of the formula, you want to now rewrite it as the left side of the formula. So cos u cos v minus sine u sine v. If you go back to your sheet here, what you're basically determining is that this is the u and this is the v. So you're going to take that right-hand side and you're going to rewrite it as the cosine of u plus v, which in this case would be the cosine of 10 plus 70. 10 plus 70 is 80, which means your final answer is the cosine of 80. All you're trying to do is take the right side of the formula, which is the cos minus sine, and you're trying to condense it down to the left side of the formula. The cosine of 80 is not something on the unit circle, so I'm going to leave it there. If it was the cosine of 90 or the cosine of 60, you would calculate it, but because it's 80, you're going to leave it like that. So this is all about formula recognition. Again, you haven't used these formulas yet, but this is your best way to try to get familiar. You might not have a question yet, so let's take a look at B. Notice that here in B, you have another cos sine, but there's an addition sign instead. So if you go back to your formula sheet and you're looking for cos plus sine, that's this one. So again, you're given the right side and you're trying to make it into the left side. So in order to do that, you're going to go back. You're going to realize that this is the u and this is the v. So this is equal to the cosine of u minus v, which is equal to the cosine of 9x minus 5x. 9x minus 5x is 4x. And the cosine of 4x is certainly not something that I know, so that's my final answer. So all you're trying to do in this exercise is take one side of the equation and simplify it down. Questions?
I just have a general question. We might just get to it later, but when you say calculate, if it's on the unit circle, does that mean we're looking for like the degrees, or we're looking for the pi?
You'll see it. You'll see one next.
Okay.
Yep. So how about number F? So if you take a look at F, you're looking for a tangent minus a tangent over 1 plus the tangent times the tangent. So again, look at your formula sheet. Look at the ones that have tangents. You're looking for a negative on the top and a positive on the bottom, which means you're looking for this formula right here. So this is the tangent of u minus v. So again, this is the tangent of u minus v, where this is u and this is v. So this becomes the tangent of 5 pi over 4 minus pi over 12. In order to add or subtract fractions, you're going to find a common denominator, which would be 12. So that's going to give you 15 pi minus pi. That's going to become the tangent of 14 pi over 12, which if you reduce becomes the tangent of 7 pi over 6. And then this is what Grace was just asking. So the tangent of 7 pi over 6, 7 pi over 6 is on the unit circle. So to find the tangent of 7 pi over 6, you're going to go to your unit circle. You're going to go to 7 pi over 6. The tangent is the y over the x. The negatives cancel. The 2's cancel. You get 1 over radical 3, which becomes radical 3 over 3. And that is what I'm looking for your final answer, radical 3 over 3. So this is what I mean by if it's on the unit circle, you're going to calculate it. If it's a value, the tangent of something, the cosine of something that you know, you should actually find it. So questions to here. Okay, take a look at L. So notice here on L, you have 2 sine 50 cos 70 plus 2 cos 50 sine 70. So you're going to very carefully take a look at your formula sheet. You are going to look for the formula that looks similar to that. What you notice is that there isn't one that looks exactly similar to that. So going back to the sheet here, you're going to realize that because there's a 2 in front of each one, you're going to go ahead and start by factoring that out. So you are allowed to manipulate the problems first. So when you factor out the 2, you're going to get sine 50 cos 70 plus cos 50 sine 70. So this 2 is just a 2. And then this inside is a formula. So sine cos plus cos sine. If you look at your formula sheet, you're looking for sine cos plus cosine. That's this one. So that's the sine of u plus v. So going back here, this is the sine of u plus v. So that becomes the sine of 50 plus 70. Again, this is your u and this is your v. So this becomes 2 times the sine of 120. 120 degrees is on the unit circle. So you're going to get your final answer by, again, leaving the 2 on the outside. The sine of 120, if you look at your unit circle, here's 120. The sine is the y value. So you're going to get radical 3 over 2. And because you're doing 2 times radical 3 over 2, that simply reduces to be the square root of 3. So again, all you're trying to do here is formula manipulation. And again, notice that because I factored those 2 out of the beginning, you can, slightly manipulate the problem by factoring things out if needed. So questions on the front side? Okay, take a look at the back side. Take a look at M, 2 sine 10, cos 10. If you go to your formula sheet, you're looking for the one that's 2 sine something, cos something, and hopefully you realize that's this one here. So that's 2 sine u, cos u, which is equal to the sine of 2u. So that is the formula that you're using, the sine of 2u. And then these are your u's. So this is equal to the sine of 2 times u, which means the sine of 2 times 10, which means this is equal to the sine of 20. And because 20 is not on the unit circle, that's as far as I can go. Compare that to n. Cosine squared of something minus sine squared of something, using a subtraction between them is not something that we're used to. So if you go to your formula sheet, if you're looking for a cosine squared minus a sine squared, that's the cosine of 2u. So if you're looking for the cosine of 2u, you have to realize that u is equal to 5 beta. So this becomes the cosine of 2 times 5 beta, which is equal to the cosine of 10 beta. Anything that's left with a variable is obviously something you're not going to be able to calculate, and it's fine. Questions? Okay, how about Q? 1 minus the cosine of something over the sine of something. So if you look at your formula sheet, you're looking for 1 minus the cosine of something over the sine of something, and that's this formula sheet right here. So that's the tangent of u over 2. So the tangent of u over 2, and u is 22. So this is the tangent of 22 over 2, which becomes the tangent of 11. And 11 is not something on my unit circle, so I'm going to leave it like that. I would say that on this sheet, about half of them, give or take, should simplify to be unit circle values, and then the rest don't. For something like number S, notice it's the square root of 1 plus the cosine of pi over 6 over 2. So you're looking for the square root of 1 plus the cosine of something over 2. So if you're looking at your formula sheet, you are looking for the square root of 1 plus the cosine of something over 2. Just as a note here, the plus or minus, we'll talk more about how you determine which one it is, but based on this example, it's the positive version. So this is equal to the cosine of u over 2. So this is equal to the cosine of u over 2. And again, u in this case is pi over 6. So this would be equal to the cosine of pi over 6 divided by 2. And when you divide pi over 6 by 2, you double the denominator and get pi over 12. Pi over 12 is not something that you know the cosine of, so you leave it there. Oops. It's not letting me write my pi. Hang on. There we go. I think one more will probably do it for you. So if you take a look at the last row, okay, V has a 4, X has a 12 and a 6. If you have extra in your formula, you're going to factor, which we already saw one, like on the front side. The one that we kind of have to look carefully at is the W. So we have sine of 14 times the cos of 14. If you go back and look at your formula sheet, there is no formula that's just a sine times a cosine. So what you're going to do is you're going to look for the one that's the closest, and the one that's the closest is this one, where there's a 2 out front. So again, if you have a formula like V or X, you can factor out the extra and then just give your answer like that. The alternative to that is something like W, where you don't have enough. So again, sine of 14, cos of 14, that is not a formula. It would be a formula, though, if there was a 2 out front. You can't, however, just add a 2 because that changes the problem. What you can do, though, is you can add a half times 2. So notice a half times 2, that's just a 1. So that's legal as long as you have both. Once you put both, then you're going to group this piece. You're going to realize that this is the sine of 2u. Make sure that's a u, not a 24. So inside the black, that becomes the sine of 2 times 14, which is 28. And then you just have to make sure you have a 1/2 on the outside, because this 1/2 has to be part of your final answer. So there is so much that you're able to do with these formulas. This is literally just the introduction, which is trying to recognize them and rewrite it. So if you go back and look at this sheet, we did between 1/3 and 1/2 of these. For homework tonight, you're going to go ahead and do the rest. So again, you're going to look at what's given to you. You're going to pull up your formula sheet. You're going to look just at this section here. You're going to identify which one it's equal to. You're going to rewrite it. And if you wind up with something on the unit circle, you're going to calculate it. And if it's not on the unit circle, you're going to leave it there.